So the biggest chunk of exponents was the ones where we had those three laws, the multiplication law, the division law, and the power law. Though before that, we also did some BEDMAS questions that had exponents. There is another part to exponents that we use a lot, and that's scientific notation. Sometimes you have numbers like this that are so huge that it's easier if we just write it with exponents. So you can see here, we need to write it in this form. We need to have some number. We've called that A, but it'll just be some number. And B will also just be some number. So it needs to be some number times 10 to the some number. And you'll see here this. And this says that A has to be between 1 and 10. That's what we're looking for here. That the number has to be between 1 and 10. It can't be 10. Has to be smaller than 10. It can be 9.9 or whatever, but it has to be less than 10, and it has to be bigger than 1. So that's what we're looking at, and this will sound a little bit strange, I understand that, but you'll see how this goes once we do an example. So it says here, we need to write this number in scientific notation. So the decimal place currently is at the end, so we can move it over 1, 2, 3, 4, 5, 6, 7. And if you did that, you get 492 dot and all those other things. So 492, and then you would say times 10 to the, moved it over 7 times. So you have a number and 10 to the number. So what we're saying is that this thing and this thing are exactly the same, just that we didn't have to write so many zeros. But there's a problem, and that's that this number needs to be less than 10. So it can't be 492. I can't move the decimal place over 7 times. Let's try it again. 1, 2, 3, 4, 5, 6, 7, 8. If you moved it over 8 times, it would go here, and that would be 49. But that's still too big, so I need to move it over 1 more. Now I have a number that's right there, which is 4. So it's 4.92. So that's how we're going to write this. We're going to make sure that we move the decimal place so that we create a number that's less than 10. So we didn't have the decimal place at the end here because that would be 492. We didn't have it over here. That's 49. But we did have it here because that's 4.92. I haven't moved it over. I've forgotten already how many times we moved it over, so I'm going to do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 times. So times 10 to the 9. So that is called scientific notation. 4.92 times 10 to the 9. These are both the same, but this is now written in a much neater, more simple way. So let's look at the next one. Here's decimal place. We need to move this over until we get to a number that is less than 10. So if I move this over to here, say, I would get 30.067. Don't want that. If I move the decimal place here, I would get 300.67. So you want to move it in a spot where it only gets you just a number that's less than 10. So I'm going to go there because that is going to be 3.0067. 0067. I don't need the rest of those zeros. So I have 3.0067 times 10 to the 1, 2. I only moved it over twice. Now, there's one part because this is not correct. So let's take a look at this first one. I had a huge number. I had, what is this, 4 billion? So I went from 4 billion to 4. I made this number small. So I need to compensate for that and make this number as large as I can, which in this case was 9. And in the other way, I had a really small number here. I had 0.03. That's really small. And I went to 3. So I made this number large. Therefore, I need to compensate the other side and balance it and make this a small number, and you can do that by making this negative. So that's always how you're going to do this. You're going to move the decimal place over till you get something less than 10, and then you write down how many decimal spots you need. In this case, I only moved it over twice. Here I moved it over 9 times. And when you do that, you need to think, did I make the number bigger or smaller? Because I need to make this thing positive or negative depending on what I did. Now, we're going to do some more examples to kind of get the hang of this. So let's take this one. It's okay if you don't know right now how to do all of this. We're going to keep trying. So I'm going to move it over 1, 2, 3, 4. So now I have 5.80, but I don't need the 0. So I have 5.8. So I take a look at that. Oh, and I moved it over 1, 2, 3, 4 times. So I had a really small number, 0.00000.00058. That's a really small number. So I made this number bigger. Therefore, I'm going to need to balance it by making this one smaller. So I'm going to make this negative. And that's all there is to it. So you move the decimal place over, so it was something that was between 1 and 10. And then I counted out the decimal places, and I made it negative to balance things out. So the decimal place is over here. I moved it over 1, 2, 3, 4, 5, 6. So I have 3.4002 times, and I moved it over how many times? 1, 2, 3, 4, 5, 6 times. And then I'm just going to erase this here. So I had 3, whatever this is, 3 million. I made it really, really small. So I'm going to compensate and make this big, make it a positive 6, and it already is a positive, so there's my answer. So that's what we're doing, and we're going to work now backwards. So let's take a look at number 2. 45, and we have times 10 to the 7. That is going to be making this thing bigger. We're going to make this bigger. So we're going to add 7 zeros. 2, 3, 4, 5, 6, 7. And so I've got, usually you can put little commas every 3. So 1, 2, 3, comma, 1, 2, 3, comma. And so that is my number. Here's my decimal place right now. And I'm going to move this over. I'm going to make this bigger by 8 decimal places. So I'm going to go, I'm not going to add 8 zeros here because this is not written correctly. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So I'm making this as a positive thing. So I'm going to make this bigger, which means I'm moving the decimal place to the right. 1, 2, 3, 4, 5, 6. There we go. And then I'm going to put a comma every 3. So 34. Now I didn't add 8 zeros because I had to move it over 1, 2, and then I could add so I moved it over twice, and then I had 6 more zeros after that, 6 more spots. Here I had the decimal place at the end, it's at 45, and I moved it over 1, 2, 3, 4, 5, 6, 7. Here it's in front, 1, 2, 3, 4, 5, 6, 7, 8. So that's how I did that. Now, let's take a look. So I've got 120, the decimal place is here, and now I got to make it smaller. So I'm going to move this to the left, 1, 2, 3, 4, 5. So I'm going to fill this, 1, 2, fill this up. So 0.00120. So if it's negative, you're going to move this left. So you move it left if it's negative, and you move the decimal place right if it's a positive. So this is negative. I'm going to move this thing left. It's 0.06. So this is my decimal place. I can move it left 7 times. 1, 2, 3, 4, 5, 6, 7. And every spot I'll fill in a 0. And there we go. Oops, I think it was there. I should just erase here and just see what happened, what I ended up erasing. So, okay, no, that's good. So that is my answer. Yeah, it's attached here. That's why. There we go. So I've got 0.0000000006. There's a lot of zeros there. All right, so I'm going to zoom out here, and those are some basic questions, but the ones I'm going to ask you on the test are more like what's down below. So this is kind of an introduction, but the majority of the questions are working with scientific notations, which is the next set of questions.